Good day, this is Dr. David Plourde, and I thought today we would discuss what causes waves. The short answer is that wind causes waves, and under typical conditions, as seen here, the waves tend to be 1 to 3 meters or 2 to 10 feet high. Though, under particularly stormy conditions, waves can be in excess of 10 meters or more than 30 feet high. Now this footage I took while aboard a cruise ship crossing the ocean. So the waves that you see here are being produced not only by the wind, but by the motion of the hull through the sea's surface. And because it's the bow of the boat that's producing these waves, they're called bow waves, though if they were coming from the back of the boat, those waves would form what's called a wake from the ship. Now, it appears to you and me that these waves are indeed propagating across the slide or across your view from the lower corner up and to the right. Well, indeed, that is the direction of the waves. However, I'd like you to know and to note that the actual molecules of water on the ocean are simply moving straight up and straight down. Of course, you can't see those molecules, so I thought I'd try to illustrate this in the next slide. In this slide, you see several seagulls floating on the surface of water. Now clearly the waves are propagating toward the beach and crashing there, but do you notice that the seagulls just move straight up and straight down while the waves propagate toward the bottom of your screen underneath them? Well, that's exactly what's happening to the molecules of water as well. They, just like the seagulls, are simply propagating straight up and straight down while the wave propagates underneath them in a horizontal direction. So wind is the usual cause of waves, but there are also some unusual or rare conditions that can also cause waves. One of such conditions is called a tsunami. Tsunamis are caused by undersea earthquakes along the seafloor or volcanic eruptions or marine rock slides that can also occur along the seafloor. So if you look at the diagram, you'll notice in the bottom right corner is an undersea volcano. This is known as a sea mount. Now, should that volcano erupt, the column of water above that volcano, outlined in red, will be displaced by the eruption. But that displacement, now shown by the second red square, is almost an imperceptibly different location from the original column of water, because in the deep open ocean, 2,000 to 3,000 meters deep or 6,000 to 9,000 feet deep, by the time the impact of that eruption reaches the sea's surface, the undulation on the sea surface will be so subtle, almost imperceptible. So in fact, the very safest place to be during a tsunami, what do you think it would be? Well, most people say if you're near the coastline, you should move away from the coastline toward higher ground, and that's the safest place to be. Well, that is true from the terrestrial perspective, but really, as you can see here, the very safest place to be is out in the middle of the ocean during a tsunami. Because as that wave propagates, this column of water outlined in red propagates in all directions. One of the directions it'll propagate, of course, will be to the left. That is toward the ever shallower seafloor, toward the continental shelf. So that these gentle undulations shown in pink toward the right side of your screen, as they propagate toward the shallower coastline, that red column of water has no place to go but up. And that's what causes the massively destructive 100-foot high waves that characterize a tsunami when it reaches the coastline. So I hope that helps you understand what causes waves. This is Dr. David Plourde wishing you a great day. Bye-bye now.